Alright, this is a continuation from the last video. We are still in section 2 of our unit 4-5 flipbook. We finished the top flap where we found how to find the x-intercepts of an intercept form quadratic. What does A do? How does A affect the graph? How do the x-intercepts affect the graph? Let's go down to the bottom flap and let's go through the process of finding the vertex for intercept form, the bottom flap of section 2. Finding the vertex, again, I think we've already gone over this in class, but if not, it's okay. This is where we're going to learn how to do this. And one of the things I want to show you is, I'll just do a quick sketch over here, that if I draw a parabola on this, let's say that I have x-intercepts that are right here and right here. And I'm going to go ahead and actually, let me change that point to be a little different place. You guys can see the difference here. Let's put an x-intercept right there. What I want you to see why this works, why can we find the vertex of an intercept form quadratic this way, is if you have any two points that are horizontal from each other on a grid, in this case, both of these green points, these x-intercepts, are horizontal from each other. They are directly to the left or right. We know the axis of symmetry has to be exactly in between these points. Give me any 2 points on a graph that are part of a parabola, and if they're exactly left and right of each other, the axis of symmetry is going to be exactly in between. So I basically can figure out approximately where the axis of symmetry is just by picking a point, the midpoint between these 2 points. Remember, we did midpoint in Intro to IM2, and I can tell you right now the axis of symmetry is going to be right there. Now, that means I know the vertex is going to be on that blue line, but I can't tell you where it's going to be on that blue line. We have to calculate that. We know the x value of the vertex will be exactly on this axis of symmetry. It always is. But we don't know whether it's going to be in the positive parts of y, is the negative parts of y, is it just close to the middle, is it way far away, up or down? We don't know that. That's what we have to calculate. So, knowing this, here's how we figure out the x value of the vertex. All we do is we add the x-intercepts together. Add the x-intercepts together and divide by 2. What we're doing, class, is we're actually getting the average. Divide by 2. That looks like a 4 there. See if I can actually make it look like a y. And divide by 2. Still looks kind of like a 4, but you know it says by. So add the x-intercepts together and divide by 2. That will give us the midpoint between these 2 points. And that midpoint is our axis of symmetry, which will give us the x value of our vertex. So take a look back at the top flap. We had our sample problem here. We're going to continue on with that sample problem. Notice that we found that there is an x-intercept at -1 and there's an x-intercept at 2. So we're going to take those two numbers, -1 plus 2, and we're going to divide that by 2. -1 plus 2 is just equal to negative. Sorry, that's not -1. It's actually +1. I just wrote -1 in my notes. So -1 plus 2 is +1. And we end up with 1 over 2. And I can just leave it that way. If you want to write that as a positive fraction or decimal, you can put 1 divided by 2 in your calculator and you can get 0.5. But we can just leave it as 1/2. We know how to handle fractions in our calculators now. Okay, so how do we find the y value? Easy peasy. Just take the x value and plug it in. So there's our equation. Plug in 1/2 for x, and when we plug that in, out will come our y value. Remember? Quarter in, gumball out, the y value will be the y value of our vertex. So for the y value, our procedure is plug in the vertex plug in the vertex X value. Plug in the vertex X value. Wow, I'm getting really messy here. Sorry about that. Plug in the vertex X value into... Actually, this is a little bit repetitive. How about if we just do this? Plug the vertex X value into the equation. And solve for y. Of course, I can just use my equation to do that. Plug in my X value and out will come my Y value. My Y value will be the Y value of my vertex. Let's go ahead and go through this process. So let's write our original equation. Let's remember what it is. I'm going to rewrite it here so you guys see it. It's y equals negative, oops, not negative, y equals 3 times x plus 1 times 2x minus 4. Now this part might get a little confusing. I'm going to put a lot of parentheses in here because I want to make sure you know how to put it in your calculator. So in your calculator you're going to write this. You're not going to put the y equals in there, but you're going to put 3. There's our first parenthesis. Remember, we always plug our x value into the equation in parentheses. So I'm going to go ahead and plug in. I'll just plug in the decimal value. So I'm going to put another parenthesis. Let me change the color so you see that. Okay? And that's going to be 0.5 plus 1. Sorry, this 0.5 needed to be in parentheses. And then we'll put the parentheses to close that. And then we'll open the next parenthesis. And we're going to have 2. Remember, there's our x value. So we're going to plug that in parentheses. 0.5, close parentheses, and then we've got minus 4, and then we have our other parentheses to close. So if you just see, if you look at the equation, the x value gets plugged into the equation in its own set of parentheses, both places, and then of course you include the existing parentheses from the original equation. If you do it this way, now at this point on the test or quiz or homework, plug that whole equation into your calculator and you will get the final answer. And I'm going to go ahead and just do the math step by step to verify we got it right, since my notes have a wrong value. So we're going to end up with 3.5 plus 1 is 1.5. So times 1.5. 2 times 0.5 is just 1. So we've got 1 minus 4. Now we got y is equal to 3 times 1.5 is actually 4.5. And we've got 1 minus 4 is negative 3. Let's go ahead and put that in a calculator. See if I can get a calculator up here. Here we go. So we're going to put in 4.5 times, and I can't put negative numbers in my calculator here, so I'm going to put it times 3. But I know that number is a negative number. So our final answer is going to be y is equal to, oh, let me check the number, I lost it, 13.5. It's negative 13.5. Okay. So we've got an x value of our vertex at 0.5 and a y value of our vertex as negative 13.5. Alright, so our final vertex, we want to write that down right here just as a reference. Our vertex for this equation, actually, you know, I should actually write it on the other side since that's where our example is. So let's go ahead and put this over in the corner. Our vertex is at 0.5 and negative 13.5. You can write that over a little bit to the left so it shows up in your box correctly. So 0.5 or 1/2 comma negative 13.5, and we just found the vertex of an intercept form quadratic. All right, let's wrap this section up. How do we find the y-intercept for an intercept form quadratic? We just figured out how to find the x-intercepts, how to find the vertex. Now let's find the y-intercept. Well, class, the y-intercept is found pretty much every time the same way on all of the forms. On the standard form, we happen to actually have it in the equation, but we still can solve it the exact same way. To find the y-intercept, you take your original equation. Let me do a different color here. You take your original equation, you set x equal to 0, and solve for y. Now why does this work? Because, take a look at our graph, our example graph. For every point on the y-axis, the x value is 0. It's the opposite of the x-axis. For every point on the x-axis, y is 0. So if we want to find x-intercepts, we just set y equal to 0. For y-intercepts, your y-axis, take a look, you don't move left or right. That means the x value of every y-intercept you will ever find on a graph forever will always have an x value of 0. So to find a y-intercept, we take our original equation, change x to 0 wherever you see it, and solve for y. What I want you to do, class, is I want you to write in this box. I'm not going to write it. I want you to write in this box in parentheses. Okay, I'm going to put parentheses and a question mark here. Just see if you're paying attention to the video. In the parentheses here, I want you to write these words. Because the y-intercept will always have an x value of 0. I'll repeat that again twice. In parentheses, please write, because the y-intercept will always have an x value of 0. And one more time, we can set x equal to 0 and solve for y. Why can we do that? In parentheses, write the words, because the y-intercept will always have an x value of 0. Let's go ahead and solve our quadratic. So let's write it out now again. We already see our original quadratic right here in the maroon. So we're going to write y equals 3. Here's an x value that changes to 0. Here's another x value. Now I got to put that in another set of parentheses because we're multiplying 2 times 0. Minus 4. Let's go ahead and work this out. So we've got 3 times 0 plus 1 is just 1. 2 times 0 is 0. Minus 4 is negative 4. 3 times 1 is 3. 3 times negative 4 is negative 12. So we just found out our y-intercept is negative 12. That means if I'm going to put your answer right here on the bottom, the y-intercept is at 0, negative 12. And that is it for the review of how to find all the parts of the parabola from an intercept form. We found the x-intercepts, we found the vertex, and we found the y-intercept. Once you find all those things, class, you can sketch a very accurate parabola that models this particular or whatever equation or function you are working with in intercept form.